Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. As usual, problem having been once again chosen from the same book, Modern Physics by Kenneth S. Crane. As usual, we first come to its statement. Okay. A double slit experiment is performed with sodium light. Wavelength lambda equal to 589.0 nanometer. Nanometer meaning 10 to power minus 9 meter. Okay. The slits are separated by 1.05 millimeter. Milli meaning 10 to power minus 3. Millimeter meaning 10 to power minus 3 meter. Milli meaning 1000 part. Okay, for example, Panadol or paracetamol is usually available in 500 milligram. It means 2 tablets of Panadol or paracetamol 500 mg become almost nearly equal to 1 gram, and similarly almost nearly 2000 tablets become equal to 1 kilogram. Okay, anyhow, the slits are separated by 1.05 millimeter, 10 to power minus 3 meter, and the screen is 2.357 meter. Okay, one is meter, one is millimeter, and one is nanometer. Okay, and the screen is 2.357 meter from the slits. Find the separation between adjacent maxima on the screen. Dear students, this problem is of nature that its solution is very short, but without having a background we cannot properly understand solution. Okay, so let us first we come to helping tools. Tool number 1, and I think perhaps there is only one tool. There are 2 versions of this tool. Okay, yes, there is only one tool, and there are 2 versions of this tool. Okay, this is our helping tools. Tool number 1, constructive interference, Young's experiment, small angles only. Okay, Ym, position of mth bright band, Ym is equal to R, where R is distance from slits to screen. R m lambda is wavelength over d is distance between slits. Okay, R is distance from slits to screen, while d is distance between slits. Lambda is wavelength, and m stands for mth position. Okay, position of mth bright band, Ym, where m is equal to 0, plus minus 1, plus minus 2, and so on. Okay, dear students, Young's experiment needs to be investigated in order to understand this problem properly. But for the time being, our topic is not to discuss Young's experiment. we have to apply only the result derived by Young in his double slit experiment. Okay, so we move to next version of this tool, in which figure has been shown about Young's double slit experiment. Okay, this is the figure. Okay, incident wave S1 S2 theta D R1 R2 P capital D Y. Okay, this Y P R1 R2 S1 S2 B theta incident wave. Okay, this is part A of this figure. Okay, in which Young's double slit experiment has been shown. Okay, this is part B of this figure. S1 S2 D theta B theta path length difference delta L. The delta L shifts one wave from the other, which determines the interference. Okay, this is R1, this is R2, this is theta, this is also theta, this is also theta. Okay, now here about figure, detail is given in words. Okay, figure so and so waves from slits S1 and S2 which extend into and out of the page combine at point P, an arbitrary point on screen C, at distance D from the central axis. The angle theta serves as a convenient locator for P. Now, wording about part B of this figure is described. For capital D very greater than small d, we can approximate rays R1 and R2 as being parallel at angle theta to the central axis. Dear students, from Young's double slit experiment, whose figure has been shown above, following three results have been derived. Okay, ym is equal to y lambda capital D over small d, and ym plus 1 equal to m plus 1 into lambda capital D over small d. When we subtract these two, that is first from second, then we get delta y, that is change in y, equal to ym plus 1 minus ym equal to lambda capital D over small d. Okay, third expression has been derived by subtracting first expression from second expression. Okay, and this third expression will be used to solve this problem. Okay, now we come to its solution in a formal manner. Okay, solution. We know that as per Young's double slit experiment, ym is equal to m lambda capital D over small d, and ym plus 1 is equal to m plus 1 into lambda capital D over small d. Okay, these two equations simultaneously imply that delta y, change in y, is equal to ym plus 1 minus ym equal to lambda capital D over small d, equation number 1. This is the same thing which we have already shown in tool, second version of this tool. Okay, now using lambda equal to 589.0 nanometer, what is this? This thing is given in this statement. Capital D is equal to 2.357 meter. This is also given in this statement. And small d equal to 1.05 millimeter. This is also given in this statement. Okay, all these three values have been provided in this statement. And we have to put these three values in this equation, equation number 1. then we will get delta y is equal to 589.0 nanometer into 2.357 meter over 1.0 millimeter. In the next step, what we have done, we have used value of nano. We know that nano is equal to 10 to power minus 9. So in place of small n, we have used 10 raised to the power minus 9. And below milli, we have not disturbed m because our result will be in meter. Okay, this m has not been disturbed. However, 1.0 millimeter, in place of milli we have used 10 raised to the power minus 3 meter. Okay, in the next step, what we have done, we have shifted this 10 to power minus 3 to a numerator, and it has become plus 3 in the numerator, while we have shifted 10 to power minus 9 from a numerator to denominator, and it has also been shifted to plus 9, but it has been shifted downward. Okay, so this thing has become before us. Okay, dear students, here in the numerator there are 2m, that is m square, while in the denominator there is only 1m. So 1m will be subtracted from m square and only meter will be left, which will be the our unit. Okay, this becomes equal to, when we solve this, actually dear students, this we have just simplified this expression. Okay, because 10 to power 6 is in the denominator, it will be treated as 10 to power minus 6. Okay, so we have made this arrangement. Okay, we have multiplied this with this. 589 has been multiplied with 2.357, and hence resultant figure has become 1388.273 into 10 to power minus 6 meter. Okay, because 10 to power 9, 10 to power 3, 10 to power 6 is will be left, and when it will be shifted to a numerator, it will become minus 3, minus 6. Okay, this has become this equal into this. Okay, next what we have done, we have shifted decimal 3 places ahead. So this has become 1388273.000. Okay, but by shifting this decimal to 3 stages ahead, will shift 10 to power minus 6 to 10 to power minus 9. Okay, these two values are exactly equal, only we have reshaped this quantity. Okay, 13888273 into 10 to power minus 9 meter. Okay, we know that 10 to power minus 9 is called nano, so here we can write 13888273 nanometer. Okay, if we divide it by 1000, then it will become 1388.273 micrometer. Okay, nano means 10 to power minus 9, micro means 10 to power minus 6. Okay, if we write this quantity in this shape, then it will not remain nano, it will be converted to micro. Okay, and if we repeat the same process once again, that is to say, we once again divide it by 1000, or in other words, we shift this decimal 3 stages backward, then this micro will be shifted to milli. Okay, so all these 4 values are absolutely equal. Just we have reshaped them. Okay, 1388273 nanometer or 1388.273 micrometer or 1.388273 millimeter. Okay, and this is the end of our problem, and this is the end of our video. Till next video, Allah Hafiz.